Today we are going to discuss the velocity analysis by using instantaneous center method. Here is the question. Locate all the instantaneous centers of a 4-bar mechanism as per the configurations given. That is, the length of the various links are AD is equal to 125 mm, AB is equal to 62.5 mm, BC is equal to CD is equal to 75 mm. AD is fixed and AB is rotating at a speed of 10 rpm in clockwise direction at an instant when the angle BAD is equal to 60 degree. Determine the angular velocity of link BC and CD. Before solving, let me tell you about instantaneous center. There are mainly 3 types of instantaneous centers. One is fixed instantaneous center. Next one is permanent instantaneous centers. And third one is neither fixed nor permanent. Neither fixed nor permanent instantaneous centers. So these are the 3 varieties of instantaneous centers. Capital N, which is the number of instantaneous centers, will be equal to n into n minus 1 divided by 2. Okay, n into n minus 1 by 2, where n is the number of links. Okay, where n is the small n is the number of links, and capital N is the number of instantaneous centers. Okay, so by using this formula we can find how many instantaneous centers are there in our problem. Okay, so first of all we have to draw the configuration diagram. Okay, so this is the configuration diagram. Here AD is equal to 125 mm, AD is equal to 125 mm, then AB is equal to 62.5 mm, AB is equal to 62.5 mm, BC, CD both are of equal length and is equal to 75 mm, and AD is fixed and AB is rotating at a speed of 10 rpm. Here AD is fixed and AB is rotating in a clockwise direction at. First question is locate all instantaneous centers. First question is locate all instantaneous centers. Okay, so this is our first question. So in order to locate this instantaneous centers, by using the formula n is equal to n into n minus 1 by 2. Okay, n into n minus 1 by 2, which is equal to, here n is equal to 4, then 4 minus 1 is equal to 3 divided by 2, which is equal to 6. Okay, it's equal to 6. So there will be total of 6 instantaneous centers for our problem. Okay, next we are going to find out the instantaneous centers. So instantaneous center is usually represented in this format, I1, 2. You have to identify what all are the instantaneous centers. So for that, mark 4 points, 1, 2, 3 and 4. Okay, 4 points.
Okay, why this 4 points? Here each point corresponds to each link. Okay, if you have got 6 link, you have to spot 6 points. Okay, so that is why each of this point corresponds to each link of your mechanism. Okay,
naming these points will be in a cyclic order. Okay, 1, 2, 3, 4. Okay, next, your first instantaneous center. Okay, so your first instantaneous center will be this one, 1, 2, I1, 2. I have already marked it. Next instantaneous center is 2, 3. Okay, I 2, 3. Next is 3, 4. I 3, 4. And next one is I 1, 4. Okay, I 1, 4. Okay, so these all are the 4 instantaneous center. 2 more instantaneous center that is yet to be found out. Okay, so before that we have to we can mark this instantaneous centers. So this is your first link, this is your second link, okay, and this joining point, okay, this joining point is actually I12, this point, okay, this point B is, okay, so the next point is I34 and this point is I14, okay. So these all are this I12 and I14 are the fixed instantaneous centers. I23 and I34 are the permanent instantaneous centers. That means next we are going to mark the neither fixed nor permanent instantaneous centers. Next instantaneous center, okay, next instantaneous center is this one and next one is this one, okay. So next instantaneous center is I13 and I24, I13 and I24, okay. So these two are the neither fixed nor permanent instantaneous centers. Extra. Okay, so now I will show you how we can mark the neither fixed nor permanent instantaneous centers. Okay, so you can see that 1 3. Okay, so how I can mark this 1 3? Okay, so while checking, you can see that there's two ways to reach to point 3, that is up from point 1 to point 3. You can go in two way, that is by 1 by reaching 2, then go to 3, okay, like this, and also this way, okay. So here the instantaneous center is 1 2 and this instantaneous center is 2 3, right? Okay, so from this you will be getting a 0.13. In a similar manner, here 1 4 and 3 4, that means 1 4 and 3 4, you will getting 1 3. Okay, same, I am cancelling the same. Okay, so this is a simple technique that you can follow. So now you can identify where this 1 2 is there. 1 2 and 2 3, where is 1 2 and 2 3? So here 1 2, this is the point 1 2 and this is the point 2 3. Point 1 3 will lie which is in collinear with this 1 2 and 2 3. Okay, so it will be somewhat over here. I can extend this line, I don't know where it is. Okay, next is 1 4 and 3 4. So here is your 1 4 and here is your 3 4. So now you can extend this line, this 1 4 and 3 4 lines passing through the 1 4 and 3 4. Okay, so this two lines will meet at a common point and that center is actually your I13. Okay, so next we are going to mark the next instantaneous center. Okay, that means next we are going to mark the instantaneous center 2 4. So 2 4 can be of two way, like this and also like this. Okay, so 1 2 and 1 4, where is 1 2? So this is 1 2, this is 1 4. Okay, so I am extending this line like this. So first one is 1 2 and 1 4. So upon cancelling you will be getting 2 4. Okay, 2 4. Similarly 2 3 and 3 4, cancelling you will be getting 2 4. Okay, so 1 2 I have drawn 1 2 and 1 4. I have extended the line in both direction. I don't know it will come on this side or this side. So next I am going to mark the next path, next line, that is 2 3 and 3 4. So where is 2 3? So this is 2 3 and this is 3 4, I34. Okay, now I am going to extend this line. Okay, So now I got another point. Okay, now this point is I24. So now I am going to fill the table, the point B, and the length used for calculating the velocity of B is AB. Okay, AB. So here in this diagram I have used a scale factor. Okay, so I have drawn this length AB as 5 centimeter in my drawing. Okay, so the angular velocity from the question itself, it is given as 10 rpm. So what is the angular velocity? Omega is equal to 2 pi n by 60, where n is equal to 10, which implies omega is equal to 1.047. 1.047. The angular velocity is 1.047. In meter, it will be equal to 0.0625 meter. Upon calculating the velocity, that means V is equal to R omega, we will get the value of velocity as 0.0654 meter per second. 0.0654 meter per second. We are again calculating the point B itself. Okay, we are transferring this velocity over here. Okay, 0.0654. Okay, so here we are going to consider the length as by using this length. That means the length of I12, I23 and I13. So here the length will be I23, I13. The distance will be I23, I13. So upon measuring this dimension, I23, I13, the length will be 8.3. Okay, so upon scaling this value, we will be getting 0.1038. Okay, 0.1038. We know that V is equal to R omega. So from that, omega value will be equal to 0.63. Okay, 0.63. So from here, we are actually transferring this velocity, this angular velocity, to the next point. Okay, so here the angular velocity will be 0.63. Next we are going to calculate the point C. Okay, C. I am going to calculate the point C, and here the distance will be I13, I34. I13, I34. Okay, I13, this is the point I13 and this is the point I34. Upon measuring this dimension, we can find that it's actually 5.9 centimeter. It will be actually 5.9 centimeter, and the corresponding value of R correspondingly to 5.9 centimeter, we can take the ratio. Okay, we can take the ratio corresponding to this first row, any row you can take the ratio. Okay, will be equal to, the corresponding value will be equal, value of R will be equal to 0.0738. Okay, the value will be equal to 0.0738. So again the velocity value will be equal to V is equal to R omega. Okay, 0.0465. Now you can transfer this value to the next row, 0.0465. The value of R, what is the value of R? So here C can also be calculated with the help of the link length. Okay, CD, link length CD. While we have drawn, we have already used the scale factor, so it will be actually equal to 6 centimeter. Okay, so here the value will be of 0.075. You can see that from the value of the question itself, it is given that BC is equal to CD is equal to 75 mm, and correspondingly in meter it will be equal to 0.075 meter. Okay, so from that omega value will be equal to 0.0.62. Okay, 0.62 will be the value. From the question, determine the angular velocity of the link BC. Angular velocity of the link BC. Okay, so this is actually the link BC, right? So this is actually the link BC. So from that you can see that the angular velocities of the link BC is same. Okay, so the angular velocities of the link BC is equal to omega BC is equal to 0.63. And next the question CD, determine the angular velocity of link CD. So link CD is equal to omega CD is equal to 0.62. Okay, so these are the two answers. I'll explain it once again. First of all, draw the configuration diagram according to the correct proportions or the correct scaling. Then you have to identify the fixed instantaneous centers and permanent instantaneous centers, which are the joining points of the links. Okay, so first you have marked this I12, I23, I34 and I14. Okay, then you have to identify the neither fixed nor permanent instantaneous centers. So for that you have to check this diagram. So next you are going to mark the instantaneous center 1 3. So 1 3, it is actually from 1 2 and 1 2 and 2 3 and 1 4 and 4 3. So 1 2, where is 1 2? 1 2 is over here. Then 2 3 is over here. So extend that particular line. Similarly 1 4 and 4 3, where is 1 4? 1 4 is here, 3 4 is here. Extend that particular line. These two lines will meet at a point called I13. That is actually the instantaneous center 1 3. Okay, after that you have to find 2 4. Okay, so 2 4, actually 2 4 will be like this. Okay, so 2 4 will be like this. So 2 4 will be 1 2 and 1 4. Where is 1 2? 1 2 is here, 1 2 is here and 1 4 is here. So extend that particular line. Then next is 4 3. Okay, 4 3 and 2 3. 2 3 is here and 3 4 is here. Extend that particular line and it will together meet at a point I24. Okay, so thus we can locate the instantaneous centers. After that you have to measure this particular dimensions. This particular dimension. From this you can find, first you have to find this omega value of this particular B, the velocity of this crank. Okay, angular velocity of this crank. Then from this you are going to find this velocity at the point B. Then you are going to find this way. Okay, then you are going to find the angular velocity of the link BC. Okay, going to find the angular velocity of the link BC, omega BC. Okay, so for that you need the distance between the instantaneous centers 2 3 and 1 3. So you have to measure that distance and use it over here, value of R, use it in place of value of R. So next you are going to find the velocity of C, velocity of the point C. Okay, with that we can find out the angular velocity of link CD. Okay, so please try to solve this problem. Thank you.